Point down. Go ahead. Point to the ground beneath your feet. That direction? Someone on the opposite side of Earth is pointing the exact opposite way and calling it the same thing. Down doesn't exist. Not the way you think. And what we've discovered above and below our solar system just proved that everything we thought about our place in space was fundamentally wrong. The boundaries aren't where we drew them. And what lies beyond isn't empty. Here's what astronomers taught for decades. The solar system is a flat disk. Planets orbit in a thin plane called the ecliptic. Above and below that plane, mostly nothing. Sparse space. A few rogue comets kicked out by Jupiter's gravity. Simple. Clean. Organized. The solar system has edges we can define. And for a long time, that made sense. Look at any diagram. Mercury through Neptune lined up like records on a turntable. Everything orbits the same direction, same plane, predictable and flat. So naturally, above and below should be empty. Except in 2012, something crossed a boundary no human-made object had ever touched. Voyager 1, 11 billion miles from the Sun. Sudden 40-fold spike in plasma density. Solar wind vanished. Cosmic radiation flooded in. It crossed the heliopause, the edge of the Sun's influence. But here's what nobody expected. The heliopause wasn't where the models said. And the shape? Wrong. Completely wrong. Scientists assumed the heliosphere, the bubble of solar wind surrounding our solar system, looked like a comet, rounded at the front, stretched into a long tail behind. That's what physics predicted, what simulations showed. In 2020, researchers rebuilt the model using data from Voyager, IBEX, Cassini. The result? The heliosphere isn't comet-shaped. It's a crescent, a deflated croissant. Wait, rewind that. The protective bubble surrounding our entire solar system, shielding us from galactic cosmic rays, is warped into a shape that shouldn't be possible. Not symmetrical, not predictable. Squeezed and twisted by magnetic fields from interstellar space we didn't account for. Pressures we measured wrong. Interactions we missed entirely. Voyager 1 and Voyager 2 crossed at nearly the same distance. 121 and 119 astronomical units, but from different angles, different plasma densities, different magnetic fields. The boundary itself changes depending on where you cross it. So when we say above or below the solar system, we're talking about regions where the Sun's influence has a completely different shape than we assumed. We thought we knew the edge. We were measuring the wrong thing. But the heliosphere is just the first layer, because surrounding everything, Sun, planets, heliopause, all of it, is something far larger. The Oort cloud, a spherical shell of trillions of icy objects stretching from 2,000 astronomical units out to maybe 100,000 astronomical units, halfway to the nearest star. It exists above the ecliptic, below it, in every direction equally. And here's the problem. We've never seen it. Not one object. Not directly. Every telescope humanity has built, Hubble, Webb, ground observatories, can't detect a single Oort cloud object unless it falls toward the Sun and becomes a comet. But we know it's there, because comets keep arriving. Long-period comets with orbits lasting thousands of years, coming from every angle, above the solar system, below it, tilted at impossible orientations. Something is out there, sending them inward. And in 2024, models suggested something that changes everything. The Oort cloud might not be a simple shell. It might have structure, density variations, regions shaped by the Milky Way's gravitational tides, forces from the galaxy itself pulling and warping the cloud over billions of years. The same tidal forces that occasionally dislodge objects, sending them screaming toward the inner solar system. That structure surrounds us, encloses us, defines the true boundary of the solar system, and it's organized by forces larger than the Sun. The Milky Way is sculpting our solar system's edge, which means the solar system isn't isolated. It's embedded in something bigger. Now, here's where it gets worse. The ecliptic, that flat plane all the planets orbit in, is tilted 60 degrees from the galactic plane, meaning up from Earth's perspective doesn't point up out of the galaxy. It cuts through the Milky Way's disk at an angle, travels straight up from the solar system's north pole, perpendicular to the ecliptic. And you're not heading into empty space. You're plowing through the densest part of the galaxy. Billions of stars, nebulae, molecular clouds. The constellation Draco hangs directly above us. Polaris, the North Star, is close. But these aren't special because they're above us. They just happen to be in that direction because the solar system's orientation is random, determined by the spin of the gas cloud that collapsed 4.6 billion years ago. If that cloud had been rotating differently, above would point somewhere completely different. Other stars, other constellations, different structures. Direction has no meaning, because above and below are human concepts, local concepts. They work on Earth because gravity gives us a reference. But in space, it doesn't exist. Every solar system has its own above. Every galaxy has its own plane. Every cluster aligns differently. We thought understanding what's above and below our solar system meant mapping empty space. Instead, we found layers. The heliosphere, warped and asymmetric. The Oort cloud, spherical, invisible, shaped by galactic forces. Interstellar space, filled with hydrogen clouds, cosmic rays, magnetic fields. The Milky Way's disk tilted 60 degrees from our reference, and farther out, the local bubble, the local group, the supergalactic plane. Each layer redefines what above and below even mean. Voyager 1 won't reach the inner edge of the Oort cloud for another 300 years. It'll take 30,000 years to pass through, 30,000 years to cross a region we can't see, filled with objects we've never observed, shaped by forces we're only beginning to measure. And during that entire journey, it'll still be inside the solar system. Because the solar system doesn't end where the planets stop. It doesn't end at the heliopause. It ends at the Oort cloud's outer edge, where the Sun's gravity finally loses to the Milky Way's. That boundary sits at roughly 100,000 to 200,000 astronomical units, 1 to 3 light-years from the Sun, and we have no way to observe it. No spacecraft will reach it in our lifetimes. No telescope can image it. The edge of our solar system is invisible. But what lies beyond? Other solar systems, other Oort clouds potentially overlapping with ours, interstellar clouds of gas and dust, the galaxy's magnetic field threading through everything. We exist inside overlapping spheres of influence, nested structures, boundaries that shift and blur. There is no clean edge. There is no empty space above or below. There's just more structure, more complexity, more forces we're only starting to measure. So what is above and below our solar system? The answer keeps changing. Every time we think we've defined the boundary, we find another layer. Every time we assume a direction is empty, we discover it's filled with something we didn't predict. The heliosphere isn't shaped right. The Oort cloud is invisible, but everywhere. The galaxy is pulling on us in ways we didn't account for. And the concept of above and below, the directions we use to organize our reality, don't actually exist beyond Earth's surface. We thought the question was simple. We thought the answer was nothing. Instead, we found that our solar system doesn't have edges. It has gradients, structures, regions where one influence gives way to another. And the directions we point to find them? They're as arbitrary as the spin of a gas cloud 4.6 billion years ago. The solar system isn't a disk floating in a void. It's a nested set of spheres, embedded in a galaxy, shaped by forces operating on scales so vast we can barely measure them. So what's above and below us? Everything we didn't expect. If you're drawn to comic topics like this, where the answer just opens bigger questions, subscribe. The universe keeps rewriting what we thought we knew, and there's a lot more out here we haven't figured out yet.